and welcome back to Applied Machine Learning from Analytics Vidya. In the previous videos, we have seen how we can use logistic regression to solve classification problem. So if we want to predict the outcome between two classes, which could be 0 and 1 or anything else, we can use logistic regression to solve that problem or to make those predictions. In this video, we'll go out and implement logistic regression on Titanic survival problem. So the problem is that you have been given various attributes of passengers who were traveling with Titanic, and we need to predict whether they would survive the tragedy or not. So the outcome is classification problem. So let's start by importing the libraries which we'll need. So it is pandas, numpy and matplotlib. I'll import scikit-learn later. And I'll read my data, which is already stored in data_cleaned.csv file. Now we have already done the pre-processing on the data, so you can see that the data is nicely arranged. However, we still need to do transformations which scikit-learn requires us to do. So we'll do that. But before doing that, let us separate the independent and dependent variables. And let's split the dataset into test and train. So we have basically test X, train Y, and test Y, 4 datasets. Now, as I said, scikit-learn requires all the values of the inputs to be between 0 and 1. So in this particular case, variables like age, where they do not fall between 0 and 1. So we'll just normalize them using min-max scalar. So you can read more about that. We have already discussed that before. And now let's look at the columns. So these are the columns which we have in the scaled input variable. And this is the scaled variables on the train file. So now you can see that ages are between 0 and 1, and same is true with fair. So this looks like the dataset which is ready. Let me also check my test variables. And these are also between 0 and 1. So we now have all the data points which we need to go out and implement logistic regression. So let me import logistic regression module from sklearn, and I am importing that as logreg. And I'm also importing F1 score. So we have already learned about evaluation metric F1 score before. If you need more information, you can refer to that module. Once I've imported these, I'll basically create an instance of it and then fit the model using the train dataset. So I'm using train X and train Y, and I can now make the predictions. So let me make the predictions. And thing to note about here is I'm using logreg.predict. So this will only make predictions 0 and 1. It's not giving me probabilities right now, and we can also do that, but I'll show that to you later. So right now I've made the predictions on my train file. So let us calculate the F1 score. So F1 score on the train dataset comes out to be 0.7485. And let me do the same thing on test. And on test, F1 score actually comes out to be 0.75, which is very close. So it shows that the model overall is good. Now, if you want to know probabilities, we'll need to use predict_proba function. So let's see how we can use that function to predict probabilities. So once I do that, you can see that I'm getting 2 probabilities, and these are basically probabilities of both the classes. So you'll see the sum of the 2 is actually equal to 1 because this is a binary class classification problem. Right now, once I have these probabilities, so I can look at them, and what you can see, so all these values are between 0 and 1, which is correct. And I can now set a threshold of where do I want the distribution between 0 and 1. So in this particular case, I say if the probability is more than 0.55, predict that the passenger survived. So I can use my own threshold as well once I have the underlying probabilities. So it is entirely up to you whether you want to do that or not. So in this particular case, the train F1 score ends up being 0.7428, which is slightly lower than what we had before, 0.7485. We can also look at the confusion metric. So again, we have studied confusion metric, and I can go and do a more detailed classification report by importing classification report from sklearn, which gives me things like precision, recall, the F1 scores, which we have already seen, but this now gives you scores at the class level. Now, if you want to look at the coefficients for each of those input variables, you can print that by using the same function coef. And let's go ahead and plot them as well. So as you can see, these are the coefficient for each of the variables. So the ones which are higher are clearly more significant. So let's print these. So as you can see, there are various coefficients and they have different probabilities. These P class 1, 2, 3 are your dummy variables, obviously. Now, as we did in the linear regression, let's look at the variables which have high impact. So again, I'll use 0.3 as the cutoff. So any variable which is more than 0.3, let me bring that in the subset. And so sorry, there is a small error. So let me change the bracket and rerun this again. So now I have a small variable sig_var and I have the subset ready. I can again use the train test function to split. And now I am creating the logistic regression instance and fitting the model. Once I fit the model, I can again go out and predict. So the F1 score has gone down slightly, but my model is only having the coefficients which are significant. So this is how you can use logistic regression to make your predictions for classification problems.